Hello, welcome back to this new video for you. In this video we are going to see how to enhance a digital image using gamma correction. Have you ever wondered in your computer screen setting while sometimes there is a parameter called gamma and you sometimes can modify this parameter and the intensity value of the screen changes? So in this video we are going to see the theory behind this parameter, and also we are going to analyze MATLAB code's example and understand how this works. In this slide we are going to understand better how gamma correction works. First, it's important to know that gamma correction is defined by the following power law expression. When S is equals to C multiplied by R to the power of gamma. This expression, this transformation function, was taken from this classical book. In this expression, it's important to notice that R is the input image or the input gray value, and S is the output image we desire. And C is a constant. It's a constant that could be equals to 1. So in this case, when we have gamma is the parameter we are going to modify in order to achieve certain effects on the image. The following three graphs, these three features were taken from MathWorks article, in which we could notice how the effect when gamma is less than 1, when gamma is equals to 1, and when gamma is greater than 1. When gamma is less than 1, we have the shape of the curve is equals to this feature we have here. This curve allows us to expand this dark input narrow range of values into these output values. So we can see that is a kind of expansion of value. We are expanding low dark values in this narrow range into a wider range of output values. So on that way, this curve is important, is useful when we want to, for example, when we want to enhance dark areas of an image. And in the MATLAB examples, we are going to see how to use a practical example of this case. So this second case is when gamma is equals to 1. We don't have too much anything to do, because is when the input is equal to the output, nothing happens. And in this case, in this final case, when gamma is greater than 1, is the opposite, generates the opposite effects from this first case. For example, if we have when we have a wide range of dark input values, we are going to compress these input values into a narrow range of output values, and this curve is also useful in practical applications. So in the following slide, we are going to see how to use this curve in a very practical example from MATLAB code. So now we are in MATLAB. Let's execute this code and let's see what's going to happen. Okay, so we have here an example of the previous discussed transformation. So I just want to show you, this is the original image. We are seeing this is a forest image, which is a default image you can upload from MATLAB. We have here the gamma correction function. Let's recap. This is the case in which gamma is less than 1. This is this first case we discussed previously, and we have we have the output here in this image. Okay, we have the output of the MATLAB inbuilt function, and we have the output of a function I implemented. I'm going to show you to you. So what happened here? What was the change? What was the important details that took place? So in this case, as we can see, there are certain dark areas that we cannot see very well. In contrast, in this output, we can see better the image. This image is more nicer than this image here. So what happened with this transformation? As we discussed previously, we have the case in which a narrow range of dark values over here, for example, these values are mapped into this wider range. We are talking about an expansion of values. So therefore, we are giving more details. We are giving more details to the dark areas. We are giving more light, and we are giving more expansion to the detail. So that's why we see in the output image, we can see much better several details in dark areas that we cannot see in the original image. So in that way, this is a very practical transformation that takes place in this particular case. So now let's analyze the MATLAB code and understand how to implement this transformation in MATLAB. So now we are going to analyze the MATLAB code line by line. First, we read the image forest.tif, which is included in MATLAB package, and we use the classical syntaxes in read. I just want to highlight this time is because this image is an indexed image, it has a specific way for reading it. So you can see how we just have the exam map, and then we use later this function that converts this value into a grayscale image. So I just don't want you to be worried about this, because you can check later on type of images in MATLAB, and you can understand very easy. So I'm going to execute this code, just highlighting and press F9. Okay, and that's okay. We have here all the variables we need that has been loaded in the MATLAB workspace. So this line, anything new, just we are going to open a new feature. We are going to show the image, and we are going to write down the title original image. Okay, pressing F9, and we have here the original image that we saw minutes ago. Okay, so this step is just assigning the value of gamma. In this case, is a value less than 1, and we just have this variable with this value in our workspace, and later we proceed to compute the gamma correction using the MATLAB inbuilt function imAdjust. Okay, this function receives the image as a parameter and receive the gamma. So you may be wondering why I am using these two brackets empty here. This is just a detail of programming MATLAB. As you can see in the help of this function, you specify, when you don't specify anything, it means that it's going to take the default values, which are the maximum and minimum of the image. On that way, these two parameters are related to the top and bottom values from the transforming function. Okay, let's recap. Let's see, for example, in this when we saw this slide, we have the bottom and the top value, and if we have a particular interest in our application, we can change these values, and we can do other things. Okay, so just for remember to you, if you want to check how this function works, you just type in your command window doc space and the name of the function in adjust, you enter, and then you can see the help of the function, sophisticated help of the function, in case you want to know deeper how this function works. So let's continue. Later, after this execution, let's press F9. We're going to have the first adjusted image, which is using the inbuilt function MATLAB, and this other line is going to execute the gamma correction function I implemented, in which I'm going to show you, I'm going to explain to you how it works. Okay, it also receives the image and the gamma parameters. How is this function? We have this function here, gamma correction, and these are the lines associated with the function. Okay, and what's the purpose of this function? We are going to enhance the image contrast using gamma correction. So why the first step we take is as the same previous videos, as the same in one of the previous videos I uploaded, we just try to make sure we are dealing with uint 8 type of image. It means that we are going to deal with image 8-bit images, and that's why we use that function in order to ensure this properly, because if we have an image of 16 bits, we need to change that value, because everything is going to change in the function, as we are going to see right now. Well, later we define the C constant equals 1. Let's first execute this one. Everything is going to be right, and we are going to execute this line also, which is C equals 1, which is this variable. We see here this constant that sometimes could have another value. If you want to make other tests, you can change that value too. So the other point we have is the R value. Okay, we are going to create a vector, in this case from 0 to 255. We execute this line, and we have a vector, a column vector from MATLAB, in which we can check out this vector if you want to see in the workspace. Here we have the vector R, which have one value, one row, and 255 columns. In fact, it's a row column, it's a row vector. Okay, so later we are going to execute the most important line of this code. This is the line that defines the gamma correction function. This line is the same mathematical expression as we can see here. It's the same mathematical expression, and on that way you can see that R values are going to be multiplied by C. In this case 1, nothing is going to happen, but R values are going to the power of gamma, and because of that we are going to have an S vector value with such operation, with such value after this execution. Let's go into execute F9, and we can see here we have S with this is a double type, but if you realize we have a minimum value 0 and we have a maximum value of 3.0291. Okay, that is not properly for the conversion, for the making the transformation, because that's why we need to rescale this image. We need to change the scale of this vector. How can we do that? Well, using this line above we have here is just we are going to make a division by the maximum of this vector, which is going to normalize the vector, assigning 1 to the maximum value. But if we multiply this vector by 255, we are going to have a full vector in from 0 to 255, and therefore we can make later we can perform the transformation. Okay, let's execute this line. F9 again. Okay, now you can see that how values were changed here in the workspace, and this is a line for showing these results. Let's press F9. Okay, and we have here the gamma correction function. The gamma correction function we saw minutes ago, and is the function which is going to transform the image. So as you can see, we have in x-axis 0 from 255, and y-axis we have 0 to 255 too, which is the last value here. On that way we can make an assignment, we can transform the image using that vector, and that is the following line we have, in which im corrected equals to s evaluated in image plus 1. So we execute this with this line, and we have im corrected, which is the result from this operation. So I just want to, probably you may be wondering why I am using image plus 1 and not just image. I just want to remember to you that in MATLAB we don't have in array we cannot use 0 as a parameter. In contrast with other languages, with other programming languages like C for instance, and Python too. That's why, for example, let's if the image has a zero value, which is possible because zero value is the black, is the maximum dark color grayscale value. If we have 0, we can ensure with this operation that we will not execute a line with s evaluating in 0. I'm just going to put an example of what is going to happen if we just perform this mistake. If we have this, we are going to receive exactly an error. We say array indices must be positive integer or logical value. So that's why I am using this artifact, this strategy, to avoid this mistake. Okay, so finally, because this value is double, it's important to ensure the final 8-bit image with this line. Press F9 and we just convert this image to an 8-bit an image of 8-bit value. Okay, so let's continue with the main program. In this case, I'm going to, because I was executing inside the let's change here. It's gonna be okay. I think is if just execute this line. Okay, everything is fine. Executing this line is exactly as that I was doing before, and finally we are just opening a new feature and showing the two images at the same time. Okay, and here is the final result. We have the transformation, we have how this transformation is much better than the original image because of the effects we have been discussing in this video. I hope you like this video, and if that is the case and if you want to continue being updated, you can subscribe to the channel and any doubts you may have, any question, don't be shy and don't hesitate to contact me, don't hesitate to ask. So bye bye.